My name's Jeremy Custenborder. I am the field CTO for Nstream. A little bit about who I am. I have been working in the streaming realm for quite a while. Before joining Nstream, I was the first field engineer for Confluent. I worked with them for 7 years, and then before that, I did work at Cloudera and worked in the big data space. Julia here really wanted to highlight that I used to be a VP of engineering for MySpace, because that's super popular today. But I'm here to talk about what we're doing at Nstream. So what we are is Nstream has built an amazing open source set of libraries for building real-time data applications. So what we've seen over time is that the current state of data is constantly evolving. We're seeing more and more and more data every day. So the top Fortune 500 companies are all working in real time, except when I really need them to. So the thing here that we talk about is with every innovations with applications, with infrastructure came a innovation with applications. So for years we had databases and data stores, and then from there we had applications that then rose on top of them. So we look at things like the big data evolution, where at one point in time, things like a Hadoop was a massive innovation, to then later have something like Snowflake come in and basically eat its lunch. And then now what we're seeing over time is this evolution of streaming data, where I've got to see over time just an explosive growth during my time at Confluent, seeing going from having to explain what is streaming, having to explain why would you want to do something like this, to everybody's like, yeah, we're doing that, we're working on that. So the next evolution on top of streaming data is a platform like Nstream. So what we've seen, and we saw a ton of this during the presentations this week, is that we have data come in from a streaming data source. Think your Kafka. This could be Pulsar. This could also be legacy JMS systems, and you have relational databases. All of this data comes in and is then manipulated by something like Flink or Spark. Then we take that data and write it back to Kafka. Then we have to have some other engine to basically give us access to the data that we just queried and we just worked with. And then on top of that, we have to build user interfaces and application servers to integrate with this data. It's error prone, there's tons of latency. Every single one of these steps adds more latency to when I'm going to receive my answer. And then on top of that, I have to maintain and work with all of these different systems. And just to give you an example, this particular architecture is from a published paper that Uber Freight uses. And this is how they move freight in their system. So if you think about how complex this would be to run at an enterprise scale, somebody like Uber has a simple mission. And they basically can focus on a finite number of use cases. Do you all really believe that we're going to run 100 copies of this in an enterprise with all of the data and data systems that we have available? This ends up being basically a Rube Goldberg machine. If you ever watched like the Looney Tunes, you have all basically something that like Wile E. Coyote would build, and this is the best that we have right now. So the challenges is that you're going to see is that I have multiple subject matter experts that I have to employ. I'm now going across multiple teams. So I don't have a single set of people that are responsible. I've got a Kafka team, I've got a Pinot team, I've got a Presto team, I've got a development team building the services, and then I also have a front-end development team. That is a ton of people to coordinate for a single application. And then the key here is every single step along this way, we're adding more latency. And then on top of that, our user interfaces, what are they doing? If they want to discover if something changes, they're continually calling to the back end. Hey, has something changed? Has something changed? Has something changed? That's worthless I/O on the back end of these systems. And all we're doing is just spending money on all of these pieces of infrastructure. There's got to be a better way to do it. So I do have to say I'm not a huge fan of this slide because we turn around and replace it with just an Nstream box. But the idea here is what Nstream does is we're a platform built on top of SwimOS. And what SwimOS does is it is a platform for building real-time stateful applications and building real-time stateful entities. And so what we do is we take some of that data processing and we take the data storage and data serving and we put that all together. And what that does is that drastically reduces your latency. That allows you to build real-time applications where data is pushed to the front end by WebSockets. So you can build these rich user interfaces, and I'll bring up one in an example that we can all play with together, is you're able to build these user interfaces that are reacting to changes in your environment. And you're basically building an object model that is reacting to changes in the environment as it's happening. So really the thing is, what are we trying to do here? So Kafka has been a mechanism to spread the wealth of data across the organization. We're trying to figure out what's happening now, and we're trying to provide context to teams throughout the organization. We need to respond to changes, detect anomalies, and understand a complete view of what we're doing. And it's difficult with all of the different systems that are out there. And building these massive pipelines is difficult. What do we want? We want to be able to have the ultimate data freshness. We want to try to be able to get real-time data access to the clients that need it with a simplified architecture. And we want data that is pushed to clients rather than pulled. So here's an architecture of what things look like today. So we have a Kafka topic on the left-hand side. A lot of things look like this. So basically what you do is we have data landing in a Kafka topic. We run some type of algorithm or in a streaming layer and go through and build another data product with it, land it in a Kafka topic. And then turn around, shove that in some type of data store like MongoDB, and then we turn around and front it with a microservice. So each single one of these components takes time, effort to manage, build, and deploy. And what ends up happening here is you have a significant amount of just busy work. Like why do I have to build all of these layers and manage all of these layers? So when we look at this, what do we have? We have a cluster of clusters. We have clusters for storage, clusters for querying, clusters for serving. It's disconnected and disjointed and spread all throughout our organization. It's like, now what do we do at Nstream? So Nstream, we're responsible for the open source SwimOS. And what SwimOS provides is that provides that stateful services, stateful entities around your data and real-time user interfaces for that data. On top of that, we have the Nstream platform. And so what we've done there is we've built a bunch of management tooling, connectors, and low-code integrations to help you build these applications quicker. So we remove the need for specific application databases. So, and how are we able to do this? We're able to do this quite well. So one of our biggest customers, they are pushing over 10 gigabytes a second. They have hundreds of millions of stateful entities, and they're processing all of this with, this slide's a little off, it says less than a second. We're less than 100 milliseconds. So what this allows you to do is have a simplified architecture. So the last thing I'm going to tell you to do is come in here and rip and replace what you've done. No. So what we do from here is we take a simplified approach. We take that data in, we take those data products you already have, we pull them within the Nstream platform, and we build stateful entities around that data. So think a customer object with Customer 360, where that data is spread across several different topics. Pulling that together and presenting that in one holistic view, that's what we're here to help you provide. Think about your bank. When I log in, at the end of the day, if I'm a front-end web developer, I want to call a service that says, give me Jeremy's info. And then I get the latest, most fresh data possible. This is what we're here to help provide. And so what Nstream does and SwimOS, we're able to build this horizontally scalable system that serves that data, manipulates that data, stores that data, and serves that data. So the idea here is do more with less. Less infrastructure. So I don't have to have a MongoDB. I don't have to have some extra persistence layer. I don't have to build another set of web services. I minimize the amount of infrastructure that we have. And the idea with that is to have less technical debt, and then also have our application spread across less teams, fewer teams. So at a high level, I want to put together a demonstration here. So if y'all would like to bust out your phone and scan that QR code. So really, what we do is we're all about creating stateful entities. And I'm going to bring up an application here. So we'll see. So as you can see now, what this is doing is each one of you have, there's been a stateful entity created for your phone. And you're interacting with one of our backend servers. And my laptop likes to not display that. And what's happening is as that state is changing, you're connecting to this user interface via WebSockets. And as that state is changing in real time, it's getting pushed to your browsers. And this is a representation of all of you out here. So what does this allow us to do? This allows us to build really responsive, really contextual applications around our data. Do we need to use the user interface? No, not at all. But the key to think about this this architecture is this is our the stateful services and the stateful entities. That's really our bread and butter. This is the bonus feature that you get, is being able to build low-code user interfaces like this that respond in real time. So, all right.